Welcome to the walkthrough for Assignment 3. The purpose of this assignment is to deepen your experience using Java functional programming features and their integration with Java reactive streams. In particular, in this assignment, you'll develop an app that uses the Project Reactor implementation of reactive streams to obtain, transform, and store images. Unlike earlier assignments, the code you write here will have a GUI and will run as an Android app. Please use this GUI along with the unit tests discussed below to help troubleshoot and debug your solution. The following resources may be helpful in completing this assignment: a detailed overview of Java reactive streams and a comparison with Java streams is available here. A tutorial overview of Project Reactor appears here. Naturally, we'll cover all this material in class as well. The image crawler app is packaged as a project using the latest version of Android Studio. The app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of this assignment, however, you only need to be aware of the following directories: image crawler crawlers, which contains the skeletons you need to fill in, as described below; image crawler source test, which is a set of unit tests that exercise the features being implemented and can be used to evaluate whether you've correctly satisfied this assignment's requirements; and app source Android test, which is an Android Studio instrumentation test that runs your app automatically. To compile this code, you'll need to use the provided Android Studio project. You can run this project by clicking on the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. The app's minimum API is 29, so you need to select an emulator that uses API greater than or equal to 29. If you've not already created an emulator, you can create it by clicking on the AVD Manager button in the Android Studio IDE. As part of this assignment, you'll need to complete the implementation of an image crawler class in the reactor crawler.java file that obtains, transforms, and stores images. This class uses the Project Reactor framework to perform an image crawl asynchronously, starting from the root URI. Depending on the parameters you use to run the tests, images from the HTML page reachable from the root are either downloaded from a remote web server or read from the local file system, and the results are stored in files on the local computing device. The bulk of the code for this app is provided in the skeletons. In fact, a complete implementation using Java 7 features is provided in the sequential loops crawler.java file. You'll therefore focus on converting this Java 7-based class to the Reactor Crawler class that uses the Project Reactor framework. Your solution should use no loops or any unnecessary control statements at all, and instead use Project Reactor's classes and operators. Skeleton code for this assignment is available here in the usual place. Please pull the skeleton code in your repository, read it carefully, and complete the to-do markers. Unit tests in the image crawler source test folder are provided to increase our and your confidence that your implementation is working as expected. You need to learn how to use the Android Studio GUI to run the unit tests locally on your computer, as described here. As usual, testing only demonstrates the presence of bugs, not their absence, so don't rely solely on the unit tests to detect problems in your code. This assignment may seem more complicated than the previous assignments. In particular, the asynchronous nature of Project Reactor and reactive streams may take some time to get accustomed to. So please start the assignment soon and ask questions in class. Feel free to reach out to me to have office hours and also on the Piazza discussion forums. As usual, the app image crawler skeletons and unit tests are extensive, though you don't need to understand all of them to complete your solution. Now that we've walked through the specification, let's go ahead and take a look at the skeletons that are provided for you. If you take a look at the image crawler source main Java edu Vanderbilt image crawler crawlers folder, you'll see two files here. The first file is called sequential loops crawler. And this is essentially an implementation of the crawler, the image crawler, that uses Java 7 features. So you can take a look there to kind of see how it would work if you were using sort of the classic Java features, the Java object-oriented features, things like for loops and if statements and so on and so forth. Take a look at that just to get the basic idea of what methods get called and the general flow of the application. What you're responsible for doing is then taking that knowledge and coming over and implementing the Reactor crawler. And as the name suggests, the Reactor crawler uses Project Reactor reactive streams features. And this is what you'll be implementing for this particular project. So in this case, what you'll do is you'll implement various methods, starting with perform crawl. Perform crawl is going to take the initial page URI and the depth to use at this point, and it's going to call the crawl page async helper method to perform the crawl asynchronously using Project Reactor features. It will then obtain a count of the number of images that were downloaded and processed, wait until all the processing is finished, and then return the result as an int value. If anything goes wrong, if there's an error, if there's an exception, then you just want to return 0. So you'll have to use one of the cool Project Reactor error handling methods to do that. And so you'll replace essentially the return 0 here with your solution. And this gives you sort of a hint for the flow of the chain of operations to call in the context of what's returned from crawl page async. Let's now go ahead and take a look at crawl page async. As you can see, crawl page async takes the page URI and the depth, and it will then recursively call the web page that's identified by the page URI that's passed in. And it'll download, or maybe a better word is obtain, and transform all the discovered images. The recursion ends when the depth is exceeded, and that should be handled, something that you handle in the code. So what you'll do here is you'll write the code that returns a flux stream of images from this page and all pages that are linked recursively that can be reachable from it. It'll return an empty flux if the depth limit of the web crawling is reached or if the page URI has already been visited. This method should use various flux operators like just, filter, map, and flat map. And this latter operator should call the images on page and page links async helper method, which appears further below. So this, of course, should not be observable. It should be flux. And this should not be observable. It should be flux. And this kind of gives you a feeling for what you want to be doing here to do the processing. Let's now go ahead and take a look at the images on page and page links async method. This will return all the images on a given page and all of its linked pages. Actually, it returns a flux that will emit all those images on the page and its linked pages. And it'll return a flux stream consisting of all the images on this page and the images you can reach from it. This method should call the images on page links and the images on page helper methods and use flux operators like merge with and subscribe on to merge all the images into a single flux stream that uses a parallel scheduler in order to do the processing in a background, in the background thread pool. Let's take a look at the images on page links async method, which is passed in a page. And what this will do is go ahead and create a return a flux stream consisting of all the images that have been downloaded and transformed. This method internally should call the crawl page async method recursively. We already looked at that earlier, and use flux operators like from iterable, flat map, and subscribe on to perform the processing in the parallel scheduler. And here are some hints about what you should be doing. You should be converting the list of page links into a flux stream of page links, and then applying the flat map concurrency idiom to map each page to a stream of images that are downloaded and transformed concurrently using the parallel scheduler. Let's now go ahead and take a look at the images on page async method. This is used to create and return a flux stream for this page using the flux flat map concurrency idiom. It should call the helper methods get page elements as URLs and download image async and transform image async, as well as use various flux operators like flat map and from iterable to perform processing on the parallel scheduler. Note that the flat map operator can be called more than once, or should be called more than once in this particular implementation. And there's some hints here that give you an idea of where those things should occur. Next method here is download image async. And what this method does is it creates and returns a mono instance that emits the downloaded image at the specified URL. It should call the helper method get or download image, as well as use mono operators like from callable, map, filter, and subscribe on to perform the processing on the parallel scheduler. Note that the map operator that you use can be called more than once. In addition, you should also use Java's optional methods. These are part of Java 8 features like of nullable, is present, and get, to avoid having to deal with null values, which can otherwise make things more complicated. So here you're going to return a flux that emits the URL, and it gives you kind of some hints on what you might want to do here. The next method is called transform image async. This is given an image, and it returns a flux stream of transform images based on the image that's passed in. This method should call the create new cache item and apply transform helper methods, as well as use flux operators like from iterable, filter, map. And you can also have filter and map be called more than once. As with the earlier method we looked at, the download image async or images async method, the Java optional methods like of nullable, is present, and get should be used to avoid dealing with null values. And this gives you some hints on things to call here that you should use. So that essentially walks through the skeleton that you'll have to implement. If you take a look at the videos that describe the various flux and mono methods and things like flat map concurrency idiom, that'll give you a lot of good clues as to how to go ahead and implement this particular downloading and image transforming strategy for Project Reactor. Now that we've walked through the specification and looked at the skeletons, let's go ahead and show how to run the. Now that we've walked through the specification and the skeletons, let's take a look at how to run the unit tests. If you go into the image crawler source test Java edu Vanderbilt image crawler crawlers folder, you'll see a file called reactor crawler tests. Simply go ahead and run those tests. You should go ahead and compile everything, and then the tests should all pass if everything has gone correctly with your implementation. As you can see here, we have 13 tests that were run, 13 tests that were passed. You might get some warning about an illegal reflective access operation. Just ignore that. Doesn't mean anything in the context of what we're doing. So this is what you should see if you can get your implementation to work properly. Now that we've shown how the unit test can be run, let's take a look at how to run the Android instrumentation tests. In this case, we come over here in the app source Android test Java assignment tests folder, and we go ahead and run the reactor tests. And what that will do is go ahead and launch everything. And you can see if we go back over here to the emulator, our emulator will start up. And then we're going to go ahead and run the image crawler in it. What it's doing is it's taking a bunch of images that are located on our local emulator environment. We could do it over the network, but it would just take longer. And then we're going ahead and obtaining those images, and then we apply various image transforms to filter and modify the images. And you can see here that there's lots of copies of things being created that are transformed. And because this is using the various mechanisms that are available with Project Reactor's concurrent flat map idiom, this is doing some cool things to make everything run in parallel. So if it all goes well, the test should pass correctly, as you can see here, and you should see some nice results.